Okay, this is Wednesday radio night Zoom for January. What is today, you guys? The what is it? 27th.
27th.
Yeah,
It's
27th. There we
birthday.
go. January the 27th. We'd like to start with Rick, and I'm going to give the host over to Rick to start his dim light bulb demonstration.
Okay.
Okay, Rick.
Right. So this is the presentation that I put together about the dim bulb tester that I built, and it's not very long. So let's see. I gotta figure out all of this. I'm going to share that screen, and we will resume the slideshow. So here it is. It's a dim bulb tester. And there's nothing earth-shattering. I'm not going to read all of this. But the important thing here is that I used David Tipton's design. And this link that I have here will take you there. I don't think I want to try that right now. But that will, if you use this link, it will take you to his YouTube video about his dim bulb tester. He did a test video on it, and it was really interesting. Impressed me enough to where I decided I needed to have one. This is what his looks like, and you can see he's got the little monitor meter, and of course he's Australian, so he's got the Australian plug, the 240 plug, but the concept is exactly the same. And yeah, he spent a little more money for his, so his looks better than mine does, but mine works. One thing he did, and I didn't want to spend this much money, but he used this quick cutoff switch on his output, so that if his bulb comes on really bright, meaning he's got a dead short, he can really quick close that thing down. This is the schematic, and it when you get right down to it, it's really clear that when the thing is set to the dim bulb setting, it simply switches this bulb right in series, puts it across the line, and puts it in series with the radio under test, which is what they all do. Now, he used neon bulbs, but he didn't show that in his schematic. And that was one thing I learned in some of the reading I was doing about neon bulbs. You got to put a resistor in series with a neon bulb if you're going to put it across an AC line. And for this particular neon bulb, the C2A, you need about a 30K resistor. So that's what I did. I got some 30K resistors and put those in series. And for the box, I used flooring samples. You can see them here in the picture. We're gonna get some flooring done. In fact, it's happening this coming Monday. And they sent us literally a box full of samples, and all of these little samples that were of the 3/8 inch plywood. I thought, wow, that's a neat way to get a nice finished box without having to do much work with it. So I mitered the edges and did that kind of stuff. It worked out just fine. These are the dimensions that I used, and these are the dimensions I used. It doesn't matter, whatever you set up for your own box, that's, you have to design it that way for yourself. And like I said, this is one of probably hundreds of different ways of going about this thing. This is the where I ordered the aluminum for the front panel. I got it from Amazon, and it's gone up a couple of bucks since I ordered it back in November. But it's this 0.063 inch thickness sheet aluminum, and it worked perfectly as a front panel. It was easy enough to work with, as hacksaw and drill, and that's all I had, and or a jigsaw with a hacksaw blade, and that worked just fine. I was able to get it to where I wanted it. And this is the back of the box, just another of the flooring panels that I cut to the right size. And you notice that there's 2 slots, and that's because I wasn't thinking straight when I cut one of them, so I had to cut a second one. But that's to let the power cord out. This is the front panel, and you can see all the switches. This one turns on the power. This one bypasses the bulb or not. And then this one applies power to the outlet. And in each, in this case, the neon light comes on depending on which way you got the switch thrown. This light comes on when you have power at the outlet, but you'll see an interesting thing here in a minute. These are the part, well, these are the sources for the parts. Amazon, eBay. I got some stuff from DigiKey. I get a lot of stuff from DigiKey. I discovered that Lowe's has a lot of rubber grommets that are particularly useful in radios. In this case, it was just a simple 1/4-inch rubber grommet with a rounded edge on it. But I've needed, at times I've needed grommets in some radios that I've been working on, that for isolation of the tuning capacitor, for isolation of the dial stringing, a variety of things. But Lowe's has these things, or these grommets. You have to go dig around a little bit, but you'll find them. I don't know if any of you order stuff from Mark Oppett, but he's got a website, and I've got a link to it later, where he's got a pretty good deal on capacitors. And also he's got a bunch of line cords. And the line cord that I used for this one, I got from Mark Oppett. That's worked well for me. This is looking at the box from the interior of the box from the rear, and you can see how I used just some wood here to brace the corners, to make up for some of the misses that I made on the miters. Variety of things. You can see how it's all wired. And then this is looking at the front panel out. And this is the drawing that I made up for my lettering on the front panel. I did this in Photoshop. I mean, you could do it in probably any other simple graphics software. But I drew it up this way, and then I printed it on the decal media on the inkjet printer, and that's what they tell you to do. This is the media, and this too I got from Amazon. It ain't cheap. It's kind of spendy stuff. But then after you print it, you have to spray it with an acrylic spray. And then when you dip the decal, after you trim the decal to the size that it's supposed to be and everything, when you dip this in water, then it's just a simple water slide decal, slides right off onto your surface. And that's what I used to do the lettering on the front panel. This is the parts list. And here's the link to each of the screens, or each, for each of the parts that I found. It's pointless to try to read all of this right now, but for those of you who want to try this at least as a beginning for searches, if nothing else, you'll be able to use that. Now, here you see my meter in operation, and it doesn't look too bad here, but if you're not looking at it straight on, it's not quite as clear. But you can see this is with nothing plugged into the box right now. And you can see here's one neon on, saying that I've got the switch set to the full power position. And this has got the outlet power is on. There's power available at that outlet right there. And here I was just about to switch it on. I plugged a little radio into it, and I had 116 volts showing on the meter at the time. And I had the dim bulb set so that the dim bulb was engaged. And when I threw the switch, well, of course, I got the bulb to light up. And the way they always work, and I'm sure most of you know this, they light up briefly for a moment, and then as the surge current slows down, they don't light up quite as brightly. Or mine goes all the way off. It looks like it's gone totally off. And this is a case where I managed to catch the picture just at the time when this was at its brightest. And this neon indicator was off because what had happened is the voltage fell below the strike voltage for the neon. It has to be, I think, about 65 or 70 volts before the neon will strike and come on. I learned some interesting things about neons working with this project. And that's it. That covers it. And if Franklin says he's going to be recording this, and so I hope that everybody will be able to, if you want to get at it, when he puts the recording up, the information is there. It's terribly simple, and it was just a fun little project to put together, and it made a neat looking little dim bulb tester.
So Rick, I want to say that Tektronix made probably a couple hundred dim bulb testers in their time. Of course, they were analog meters. They had a variac built into them, but they had 3 bulbs, 100 watt, 200 watt, and 300 watt. You could switch in and out. So what do you suppose they used them for?
I have no idea.
The biggest use, I mean, you're looking at this chassis, this vacuum tube chassis. There's no tubes in it. It's just this wiring harness and all the sockets wired up. And what you want to do is power it up with no tubes in it and see if the bulb lights. The big problem was miswiring a heater somewhere would burn up the whole wiring harness, okay? But with the dim bulb tester,
Right.
it would not burn the harness up.
That's right.
I mean, you got a lot of tubes in those scopes, so you got a lot of heater current, to supply.
Yeah.
And so you put a short across those heater wires, you're going to make smoke.
One thing I was thinking about watching all of that is the light bulbs now today. is I ran into this because my mother-in-law was looking for a regular incandescent bulb for her lamp. That it's one of these touch switch lamps, you know, that she had. So I go down to the hardware store, and they had some incandescent bulbs, but you had to pay. They were charging, what was it? It was like $3 and something cents a piece for any of the incandescent bulbs, which no, I know it wasn't for the touch switch. It was for a dimmer bulb. Well, come to find out, instead of buying that, she wanted 4 of them. So, you know, you're talking like $15 or whatever to get 4 of those. So they had LEDs that were dimmable. And so I bought some of those and took them home, put them in in her lights with the rheostat switch on it, and they worked fine because they had made those LEDs. But on these dim bulb testers, I don't think that using any of these LEDs, dimmable or not, are going to work at all.
You've got to have the incandescent bulb.
You better go out and see if you can find a source for some incandescent bulbs someplace, because I know down at Ace they didn't hardly have them, and if they had them, they're charging through the nose for them. It isn't like you can find these things readily available anymore.
I don't know. Lowe's seems to have quite a number of them.
They might,
Yeah.
and this was only Ace, so that was kind of a question too, not just a statement. But
Yeah.
you know, if anybody had a source, so if Lowe's is still selling incandescents, you know, maybe you want to run out and buy a whole bunch of them and buy them up, so that, you know, eventually, because if they do become obsolete,
Kind of like toilet paper.
yeah, that too, that. But they may, as time goes on and everybody starts switching over to LEDs and stuff for everything, then they might get hard it might get hard to get. So I don't know.
I think they're going to keep doing it for replacement purposes.
You would think.
Especially specialty bulbs. You know, that you can't get a damn compact fluorescent to fit in the hole and to begin with.
Mm-hmm.
The big thing, or LED, the big thing I've run into is they're so goddamn noisy. Electric.
Yes.
Yeah,
Yes,
they are.
Oh, my God.
I ran into that too.
So in the museum, I'm listening to this FM station. It's only a 10 water, okay? And the guy next to me, his bench, he's got a bunch of LEDs. Anyway, it's not a big problem right now because he's not there when I'm there, you know? We're in isolation. But I turned his bench on to get some power from it, and that damn LED came on and the station went away. It absolutely
Really?
went away, yeah. And then I was working on some other LEDs here, and I put the spectrum analyzer on them, and there's no filtering in them.
Yeah, they're horribly
Yeah.
noisy.
They're really
Yeah.
ratty.
I find them to be noisy when I turn them on in my shop because I have an LED in my shop, and I thought that was going to be quieter, and turned out just the opposite. They make more noise and makes a lot of quite a bit of noise on AM. You know.
Yeah.
Oh boy.
I've got an LED shop light set up on my workbench, and when I start to align a radio, I have to turn it off.
Yeah.
So is it? I had those. You know, you have those where the bulbs that you screw them in, but then they got the 3 things that come out, are like brighter than bright, so I can actually see now out in my garage. That's where I got my shop. But I'm wondering if those are just as noisy as the the screw in. It's in a metal case. The whole thing's in a metal case. I wonder.
Well, you know, the screw ends, they don't have any room to put any kind of EMI filtering. You know, it just, everything's packed in there so tight. They just don't have room for the extra components.
If it's a metal case, though, it should do the radiated EMI, right? I mean,
well, it can conduct out the power line.
That's true. That's true.
Yeah.
Hey,
That's what
Mike.
these are doing.
Mike, going back to your talk, what was that digital meter you had?
The digital meter is the thing I found on eBay, and they're cheap. You know, they run anywhere from about $10 to $25. And all you have to do is look up for an AC meter, and you'll get all kinds of hits on eBay. And you know, they're Chinese made, and don't expect a whole lot of them, but
Yeah, what isn't? Okay, thanks. I didn't realize it was that easy to come by.
oh yeah, they're ridiculously easy to come by.
So that's in your parts list, Rick?
Yeah, that is in the parts list, and I've got a link to that particular one. But as I said, there's dozens of them.
So I wonder if you
By
want
the way,
to.
Franklin, I gave you the host back.
Thank you. Rick, I had a question for you though before we start Bruce's. What was the most difficult part of the whole thing?
The woodwork.
The
That's what I was thinking.
making the box, huh?
I don't. Well, a project I've been working on for the past 2 weeks or longer now is I've been building a table that I can put my circular saw in and have a table saw, because I don't have a table saw. Or I didn't.
Mhm.
Now I do.
Ah,
And without a table saw, trying to do a mitered cut to get the angle, it's almost impossible, especially on a small piece of wood.
yeah.
So the woodwork is always the most difficult for me, because I don't have any tools that will allow me the precision that I want to get in building something like that. But I'm working at it.
How do you discover to use the 30K resistors on those neons?
Google.
No.
I just started looking up. I looked up specifications on that particular neon bulb, and I found it a couple of times now. There's a chart that tells you what resistor you should use for a particular line voltage with a particular type of bulb. And 30K was the recommended resistance for that neon bulb, and that worked just fine.
You said that was one of the things that he didn't have in the schematic from Tipton, but then
Right.
you had to figure that out kind of on your own, or
That I did figure out on my own. And as he says in his presentation about it, you can use neons, or if you can figure it out, you can use LEDs as well. I just didn't feel like going through all of the rectification and everything else that it would take to get an LED to work right. And a neon bulb was much simpler to use.
Mhm.
Okay. Anybody else have any questions for Rick there?
While you're talking about neons, the first tech scope had 5 of them in series for the horizontal deflection system. And basically, the neons were biased DC wise, and they act like Zeners. So you got
Really?
5 of them in series, get way down minus, I don't know, minus 600, I think is what the requirement was. I don't remember what voltage they started from though, but anyway, they make good Zeners if you're careful. If you add capacitance to it, why then it can start being a relaxation oscillator.
Yeah.
Yeah. Right.
All right, Bruce, it's all up to you. Bruce is going to talk to us about the 570 curve tracer.
You want to share or allow me?
Oh,
to
sure. I'll give you the host there. Just be sure after your talk, you give it back to me.
Well, you're going to have to tell me how to get it back because.
Okay, you just click on my name and then it says make host, and
Okay.
it's pretty easy. So there you go, Bruce.
All right, where am I? Oh, right there.
Are you host? Yep, you're host.
Okay, we got that full screen for you.
Oh yeah, wow, looks good.
Nice.
I may make it real big if that didn't, hopefully that's it. Okay. So what we have is a 570 characteristic curve tracer here that tests vacuum tubes. And anyway, let me go a little bit over the settings. Down here in the lower right, we have the vertical setting and we're at 1 milliamp per division. This is going to be on both scopes here. And the horizontal is at 10 volts per division. Okay. So across the screen here, we've got 100 volts. A milliamp per division here, we got 10 milliamps peak at the top of the screen. Okay. So this is given, you know, a picture is worth 1,000 words. So which one is the triode and which one is the pentode?
Ooh,
Triode's on the right, pentode's on
no.
the left.
on the right. That's
That's-
what I thought.
That's correct. Okay. So we got a 6C4 and we got a 6AU6 for the pentode. So if we look at the triode here, the 6C4, and we look at this top waveform, this is zero bias. In other words, the grid and the cathode are at the same potential. So it's basically, it's a rectifier. Okay. This is what a rectifier would look like. So as we
Okay.
make the grid negative, and let's see, where's my step for the grid? Oh, right here. So we're stepping half volt increments. So you start at 0, a half a volt, and you continue on down. So these are the different voltages on the grids that make up these characteristic curves. That makes sense?
Yeah.
Yeah.
Okay. So we're sweeping the B plus. It's actually 120 hertz coming in here, rectified. So this is actually sweeping at line rate. Chook, 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 chook. And if we look, the other thing down here is we have peak volts here at 100. And down here we have, over here, we have the series load of 2K. So basically that voltage that's coming in is in series with 2K. So as we look at the peaks here, this is where the 2K is limiting it. I should have really adjusted this so we could look at the gain. But basically between, say, zero bias and minus a half a volt, we've got this
0.5.
difference here, but we've got this difference horizontally also. That horizontal distance then would give you the gain. So as you add more R, this load line would go more this way. And you would have more gain, voltage-wise. Does that make sense? As the current goes up, if you've got higher resistance in series, this is not going to go up here. It's going to go down here somewhere. So we've got this slope that's going to change with higher R. Okay, so let's see, let me make sure here. All right, let's go over to the pentode.
Hey, Bruce, before you get over there, quick
Yeah.
question for you. Obviously, the distance between the lines as the bias gets greater and greater and greater, the distance between the lines is less and less. Does that represent distortion then in the amplification?
Sure thing.
Okay.
You've got a nonlinear things going on here. As you increase the impedance in series, that wouldn't be quite as much of a what's shown here. Okay. The gain would be more linear. Right here, we've got way too low of an impedance. Typically in your triode, you're 100 or 200K pull up, right, on the plate. And here we're down at 2K right now.
Oh,
Okay, so over at the pentode here. So why is it flat?
Bruce, can I go back on the triode?
You bet.
That load, isn't that in series with the cathode?
No, it's in series with the plate.
Oh,
oh, it's plate load. Okay.
Okay, another thing here. Okay, why does the plate current go up with voltage? Well, to begin with, you've got this electron field down by the cathode, and it needs some positive voltage to pull those electrons away. So zip-a-doo-doo-dah, we could pull a lot of electrons away with zero bias. But if we put negative on the grid here, say like in the center of the screen, there's no current flowing when I've got this bottom bias until we're out past 50 volts. So why not? So that grid is sitting out from the cathode a small distance, and it's minus voltage compared to the cathode. So those electrons, they see a more negative grid and they can't get out. Okay.
Right.
All right. The negative grid voltage is repressing or repulsing the electrons right back to the cathode. Now, if you increase the voltage more, it ends up sucking between those grid lines some of those electrons. In other words, the field is increasing, and no longer can the grid hold those electrons back. That makes sense?
Yeah. More lower grid voltage when you're going minus like that is like a suppressing the electrons, just like a
Right.
right.
But if you put enough
Basically.
plate voltage up, some of those electrons are going to get through because the grid is not a very fine mesh. If it's a coarse mesh, some of that field gets through and pulls those electrons out. So there's a problem with filament type tubes. If you have a filament type tube, what voltage is the cathode? You've got 5 volts across this filament, okay? And so where's zero bias? Well, so that's one reason why most filament type vacuum tubes are 1.5 volts, so that you don't have too many volts across that, which is going to screw up with your bias or your cutoff and your characteristic curves.
I've seen where the filament type cathodes, like a 47, they will engineer a center tap on that heater coming out of the transformer, and then they'll put a resistance on that to be able to control some of the bias on that heater for that tube.
That's more for hum than anything else.
Yeah,
Okay.
it is probably more for hum.
But you're talking a power pentode here. So 5 volts is not as much of an issue.
Okay.
You take your other filament tubes, and typically they're 1.5 volts or they're 2.5 volts, something like that. Pretty small voltage. So that helps in the characteristics of the tube. We ready for the pentode?
Yeah.
Okay, so it's pretty flat here. Why is it so damn flat?
Reaching cutoff or
You got basically you depleted your
Flattens
electron
out.
source, right? So you're gathering all electrons that your plate could gather.
So if I was to take the screen grid on this is sitting at 100 volts. So if I would take the screen grid and tie it to the plate, it would look a lot like the triode.
yeah, it would be like a triode.
Mhm.
So why does the pentode look like this?
It's like he said, like I think Franklin was talking about, I think it's reached saturation at a certain point.
Well, it's 100. If the screen's at 100 volts, then it'll
Okay, so
it's all
What's
going to
the,
the screen.
we've got our normal control grid,
Mhm.
and then we've got this screen grid sitting out there. That screen grid is setting the electrostatic field in that tube. Okay, so it doesn't matter what the plate voltage is. The screen grid is going to set that field because it's in between the plate and the cathode and the first grid. Okay,
Right.
so now the plate current, since the plate current variation doesn't get back to G1 in the cathode because the screen grid is shielding it. See that?
Mm-hmm.
Okay, so let's look at down here at 0. We go to 20 volts and nothing's happening here, even at 0 bias. What's happening here?
is the
It's all
screen
going to
grid,
the screen.
All the current's going to the screen. Exactly. Because the plate voltage is so low, it can't see through the screen.
Don't you also have the suppressor in there that also that basically distorts the field between the screen and the control grid? Grid one?
The suppressor is actually in there to stop
Capacitance.
electrons from bouncing off of the plate, secondary emission, and coming back to the screen and overpowering the screen.
Also, the suppressor's between. That's right. Suppressor between the screen and the plate.
Correct.
Right.
Yeah, it's the same voltage as a
Cathode. It's usually
Cathode,
tied to the cathode. Yeah.
Yeah, that's right. Okay.
So the first 20 or 30 volts here, the screen is pretty much taking the current. But then this is the operational portion that you're going to run the tube at anyway.
Oh, okay.
And you notice it's also nonlinear
Mm-hmm.
with the steps in the grid voltage.
Yeah, by quite a bit more. But
Well, this is, what do you call it, a remote cutoff pentode. This isn't an audio pentode. Audio pentode would look a lot more linear.
oh,
But
okay.
this is set up so that changing your grid bias changes the gain of your tube dramatically. So when you tune into a strong station, you can send a little minus voltage out to this tube and reduce its gain.
Through the AVC.
Through the AVC, exactly.
So could you talk about like when you have that linear region of it's going up and down? Why the you get those lines diverging? Like on the 0 volt grid, you can see how when it goes up, then it flattens out, right? Flatten out, but then as it going linearly upwards, move over to the left about. Yeah,
Oh,
right in that
okay. Where you got the two here. This is just part of the voltage going up and coming down. It's not tracking quite like it should on this particular scope.
Is that a capacitance effect then, or?
Yes, it is.
Okay. So that it's actually the lower part is the lower part of that line is the going up, and then the upper one is coming back then.
Correct. Mhm.
Okay.
We're at pretty low currents here. And as
Oh.
you raise the currents, these would tighten up. So if I was down here where all this patch stuff is, if I was to take the screen grid and tie it to the plate, it looks almost identical to the 6C4 over here.
Mhm.
You know, I'd be willing to give my oldest daughter for one of these.
I know they're really cool.
Oh, wow. Good one. That would be nice to have, wouldn't it?
Oh,
So
this
these-
is so cool.
Yeah,
So
they're
these-
very cool.
These go for a little money. The audiophiles, they really, they use them for matching tubes.
Yeah.
Oh, by the way,
You were saying, that's right. You were saying that. Yeah.
okay, so I got my Hickok tester and I'm gonna test my tube here. So what number is it gonna give me? Is it gonna give me this number right here?
No, it's going to give you on the slope, right?
Well, I don't know what number it's really gonna give me. So if you're
Um,
matching this point, what about the points around it? Is that really gonna match?
Well, you got your signal voltage on your Hickok, right? So you're varying that, and then you're on this one you have a plate that's DC, right? So you're it's not like an AC signal. Your Hickok's got an AC signal on its plate. But you
Well,
just
we've got an AC signal on the plate here too. It's going from 0 to 100 volts in this case, sweeping back and forth. So what point you ought to pick?
well, for a Hickok, could be 180 volts, right? You're typically it's right around 180 volts, I think, for your plate voltage.
Okay, well, we can crank it up to 180 volts. But if 180 volts is right here,
That's your RMS voltage, 180 volts, right? It's
where,
so be
which one do you want to pick?
what's your
at
At
this
your-
bias?
depends on which Hickok you got, but the bias is a lot of times it's a filtered DC with an AC on top of it, so it's going to be sweeping that your signal voltage back and forth.
Right, it's going to be going up and down here.
Yeah.
Okay. But what about down here? You may not be matching here. You may be able to match right here, but what about up here or down here?
Yeah, down below you don't know what you got going on, right?
Or-
because
or
unless your
out-
signal voltage is really small.
Or
Yeah,
out
well-
here at a higher voltage? You don't know what these curves are looking like. And so you're kind of matching really one point on a tube tester. Whereas you've got a lot of things here that you can show the shape of the curve
Mhm.
and how the curve compresses with different biases. So to really match tubes, you'd like to match this waveform
Yeah.
tube to tube rather than trying to match this point right in here because you
Mhm.
don't know what's going on beyond it.
Yeah. They have a certain area, I imagine, in the tube tester. And I don't know what it is, or maybe it's in the middle, and then they will give you a minimum of emissions that is required on that setting, like you say, to let you know whether the tube is good or not, or they're judging it on that. But that like you say is only sitting in one point there, whereas this test here gives you the whole
Right.
the whole scope of it.
Pictures worth 1,000 words.
But
Yeah,
the
that's
fact
right.
is for your circuit under design, right? If you design a circuit and if you have like if you have a 250 volt plate voltage, and if you have that, then it's a valid test, for if you can set up. I have a TV2,
Uh-huh.
So I can adjust the plate voltage, and I can adjust the grid voltage, and I can
Okay.
adjust the screen, and
So you could take several points and plot it then.
yeah.
Yeah.
So that's a lot better than a single point test on a regular tube tester.
Mhm.
And you got the, what is it, the Amplitrack, or what's that other?
Amplitrex.
Yeah, Amplitrax, yeah.
Yeah.
Tied to a computer, and you're basically plotting this stuff.
Yeah. And then you can print it out.
Yeah.
Well, actually, there's a
It's one
guy
of
in Taiwan that sells this e-tracer,
Uh-huh.
and that is cool because he has a box on it where it'll make all. You just put the tube in there, and it makes all the switches, so you don't have to do the gymnastics of putting all the wires on the bottom. It just does a switch automatically, and then he
Okay.
runs curve trace. It's not an analog signal like this; it's digital.
Yeah,
And
sure.
then there's a guy that's also called the Mu Tracer. He's, I think, Denmark, I think, and he's just releasing a new one that I think the plate voltage can go up to 1,000 volts. And
Wow.
yeah, and he can also go a positive grid on it, I believe. I think he can run a positive grid on it too. So if you want to,
This can do positive grid, but it's only limited to 500 volts.
which is more than sufficient for most
For most
situations.
So Bruce,
Yeah. So Dennis Tillman, he has developed a circuit that you tie into your curve tracer, and then your curve tracer that plugs into a standard semiconductor curve tracer. Okay.
Wow.
So it, you just look up your tube chart and you plug your tube into your tube tester and then hook it up to your curve tracer. It doesn't have to be the expensive vacuum tube curve tracer. So a standard semiconductor curve tracer, you can modify, and basically you need to supply heater voltage, but you've got
The screen, it provides screen.
and a screen voltage if you're going to do pentodes, but with triodes, all you need is a heater voltage.
Mhm.
Any other questions here? Let me see if I covered everything.
I think so. So Dave, on your TV too, you have adjustments for plate current and that type of thing, you said?
Not for plate current, it's plate voltage.
Plate voltage, okay.
Yeah,
Okay.
and actually on a TB2, if you look on it, on the lower right-hand corner, there's a 2-prong plug.
Mm-hmm.
And there's actually a resistor in the plate circuit. It's a 47 ohm resistor.
Okay.
So what I did is I broke that into a 10 ohm, a 12 ohm, and a 27 ohm. So I got 49 ohms. Right, and then I just took 2 wires from across the 10 ohm, and I took it to that 2-prong plug, so I can plug in I can actually deduce what the plate current is.
Hmm.
It's 10 times the plate current, in millivolts.
Sure.
And so I can actually measure plate current. I can do plate voltage, and I can do bias voltage. I can change that, and I can also change the voltage on the screen. And then the signal voltage you can change too. You can change your degree of signal voltage. There's 5 different ranges. It goes from 1/4 volt up to 5 volts.
Yeah.
But there's a rheostat on that too, so you can change that. So what the nice thing about the TB2 is because you can measure the plate current like that.
Mm-hmm. Yeah.
The GM is equal to DI dV, right? So it's the change in the plate current divided by change in the bias.
Yeah, exactly. I wonder because I've got a TV7 and it doesn't have anything like that on it, So that's why I was kind of interested to see if that was a difference between that model and the TV7 like I've got. So
I can deduce GM independently because I built a calibration GM solid state calibration tube GM.
Okay, cool.
And so I calibrated my tester, so I know that if I tune my shunt resistor, right, my shunt pot to a certain value, that on that range, that my GM is between a certain value and the maximum value. So it's linear. Everything's linear.
Nice.
And then I can also do it by the grid shift method, where I I just changed my grid just a little bit, and I can measure my change in my voltage or
Yeah.
my current, my grid plate, my plate voltage, my plate
Mhm.
current, and then I can calculate GM that way too. So
Hmm.
we got a couple independent ways of measuring GM.
That's interesting. Yeah.
So anyway, with Curve Tracer, you can switch
is
it
so
over to look
cool.
at grid current rather than plate current. You can switch, well, screen current or G1 current if you're driving it positive, or G1 positive. And you can get quite a number of calibrations of different, or just quite a number of different displays.
This is really cool.
So Bruce, I have a question. It's kind
Nice.
of a basic one, but if one of those is out of range, would it be common that the other ones are out of range? You know what I mean? They if you like the common tube tester would only pick a medium of them, but would it be common for them to have the lower range to be whacked out, or would they all be kind of linear?
Oh, typically if you're looking at a weak tube, yeah, they'd all just kind of slide down together.
Hmm. Okay. Good question.
Anything else on this? Stop share. Okay.
Can we come down and play with it?
Now when
Bring
we
a box of
reopen,
tubes.
I'm sorry, I didn't hear you, Bruce.
when we reopen,
Okay.
Good. Good.
okay,
Well,
you're back,
fantastic.
Strickland.
That's fantastic, Bruce. I really enjoyed it,
Yeah. Really good.
and Rick too. That was very great presentations.
Yeah. Yeah, like I said, Tech had a bunch of those dim bulb testers.
Do they
came
still
with
have
a
them?
Variac. They had a Variac,
That's funny.
one, which was nice too, but
Do they still have them, Bruce?
I have one on my bench.
Oh yeah.
Yes.
Be nice to see it sometime.
Yeah. I don't think Tektronix uses them anymore, but we have several there in the museum that we use locally. It's nice to plug it in, a scope that hasn't been used in 40 years, and crank the Variac up a little with the dim bulb and let it sit there for a while and watch the temperature of that bulb go up or down, depending on whether you got shorted or electrolytics that are failing. You can kind of rejuvenate the electrolytics by bringing them up low voltage and in most cases, but not always. But if you've got it tied in with the dim bulb, and you see the bulb getting brighter, you know, electrolytics probably going south. I've had some pretty hot electrolytics. Not in this background, but when I was at Tech early on, I was doing some experiments, and anyway, electricians had just rewired the lab. And anyway, I plugged this open frame power supply in, and I'm starting to do my experiment, and I noticed it was kind of humming. I never noticed that before. And all of a sudden, of course, electrolytics back then didn't have vents. Anyway, this thing goes up through the ceiling, spreading crap all over. Anyway, I just need to get this experiment done, okay? So I go grab another one, and this one was enclosed. And I don't know, it was 3 or 4 minutes later, and kaboof inside, you know, and smoke comes out. Anyway, a buddy of mine came by at about that time. He said, "Oh, I got old dependable over here." And he plugs it in, and I said, "Did it hum like that before?" And he says, "No, I don't recall it doing like that." And all of a sudden out the side went this electrolytic spewing its guts. Well, they had taken 2 phases of the free phase and brought it to us. So we had
Oh no.
208
Oh no.
rather than 120. They had it totally rewired. The whole room was.
Oh no.
I bet you didn't rewire those.
Oh boy.
So anyway, that's what happens with licensed electricians, you know. We got our hands slapped pretty bad if we did anything, but we didn't have anything like that happen.
Gee whiz.
Early on in building 50, it was all 2-wire initially, you know.
Yeah.
Oh, we got to get up to code with 3-wire. Anyway, the electricians came through and rewired benches and stuff. And, you know, the ground wire could be anywhere. You just name it. They just, it was a total disaster.
Wow. Reminds me of my first house I bought was built in 1935. And I went in to sign up. I bought it, went in to sign up for homeowners insurance. And a lady goes, well, has the wiring been updated? And I go, yeah, there's a breaker box with Romex all in the basement, you know, and feeding out to everywhere and everything's fine. And so long story short, I kept blowing a circuit breaker in the kitchen. So I had to come to find out that everything was, the whole kitchen was on one 15-amp circuit. So I thought, well, I've got to straighten this out. I got to put another one in. So I went up in the attic because that's where the wires were feeding out of the kitchen. And everything in the attic was all knob and tube wiring. And what they had done, they had, get this, what they had done, they ran Romex out of the basement up through a conduit into the attic. And then they just split the Romex off on each side. And then they wired it right into the knob and tube in the attic from there on, left it that way.
Jeez.
And that could have been a disaster, you know, if the house caught fire or something happened, because then they could have denied my claim because, you know, so I had to go through the whole attic and rewire the whole house, you know, and get it all back up to modern wiring, you know. So, and what a chore that was.
My folks had this farm and it had an old farmhouse on it. And it was all knob and tube. And anyway, they rented it to my sister and her husband. And, you know, I said, you can't plug anything up in the attic. You can't plug a heater out there. Lights are okay. Well, somewhere along the line, they plugged a heater in. Anyway, I don't know what this is. Must be 16 gauge. I don't know. You know, with the rubber on it.
Yeah.
Anyway, the wiring caught fire. Anyway, running up to the attic with a hose, putting this thing out.
Gee whiz.
After that, I went ahead and rewired the old farmhouse because
yeah,
you don't know what people are going to do when you're renting, you know.
Right. Yeah.
Yeah, speaking of hoses, this morning, a pipe burst in my wall down the basement. And the water was running out over the door frame of all places, where there wasn't any reason for it to be there, you know. And it took quite a while to trace all the piping down. Then I had to cut a hole in the wall and one in the ceiling and get in there, finally cut the pipe out and replace it.
Oh boy.
What a mess.
No kidding.
The house isn't that old, it's all copper. But when I noticed in getting the old pipe out, they'd put it in a bind, you know, where they had to force it in place. And over the years, it you know, heated up and cooled off and so forth, expanded and contracted. And the darn thing had a crack all the way around it where it went through a board.
Oh, boy.
Finally carried away. But
yeah, what happened at our house, Richard, is they have one of those pumps that circulate your water. You know, and the plumber left crap in the line. So over the course of years, that will that in an angle in the middle of the ceiling above our kitchen wore a hole through the pipe.
Oh, no. That'd be bad.
And every house in the neighborhood is built by the same guy. and they all have the same thing. You know, they're
Wow.
kind of one of those houses that, you know, like they all kind of look, they're not all exactly the same, but you know, like 4 floor plans and,
Yeah.
you know, but they're all real similar, right? And yeah, every house has had the same problem, the same location.
Gee whiz.
So my neighbor, he came over. He's got lights going bright and dim. Sounds like an open neutral. And anyway, I ran an extension cord over to his place, and I took the ground from my extension cord to his water pipe, and the water pipe's going woo-wah, woo-wah, you know. Anyway,
Gee whiz.
I said, you better turn anything you want to keep off, you know, anything valuable. Anyway, and
Oh,
called
boy.
PGE. Well, PGE came out, and yeah, there was an open neutral, but I think the neutral was open a long time, and the water pipe was returning the neutral. Anyway, that winter, it got really cold, and the ground was frozen like a rock, but he had a fountain out in his yard going up. Well, this current going through this pipe all that time at a junction, you know, had eaten it apart and failed. And so anyway, I ran a hose from our spigot to his spigot with a gender changer so that he could have water. We shut it off at the road, and we shut it off at the entrance to the house. And he just had to keep a little water running so that the hose wouldn't freeze up. But
Right.
until they could, of course, everybody else had frozen pipes. So when can you get a plumber out there, you know? And of course, they've got to dig in the yard and all that.
Good grief.
But anyway, it was the current going through that pipe that made it fail
I'll be darned.
all that time.
Yeah,
That's
that's
I suspect all of you have had neutral problems at some point in time, but my son-in-law is a pastor, and he was down at a church office down in Southern California, and he has a Apple Mac laptop, and those had at that time had the magnetic power cords that would suck up onto them,
Oh, yeah.
and it just literally melted the corner of that. And it took me a little while to finally realize that what had happened was they had lost the neutral in the building, and we were getting 220 across the power transformer, and the regulator was trying to take that down to its low voltage and sucking all the current it could to try and get it to regulate down to low enough voltage.
Wow. Yeah.
Took us a while to figure it out.
Over 100,000 people have left blood thinners behind.
no kidding.
Yeah, they shouldn't use a water pipe for a ground.
No.
Usually they've got a dedicated ground buried. Because a lot of times what happens is people will cut out a section of the old crappy pipe and replace it with plastic pipe, and the ground is still on the other end of the thing. And something goes to ground and it heats up that section of pipe. And if you turn the faucet on or whatever and are grounded, you'll get shocked real bad
Yeah.
because they've isolated the pipe. See?
Well, I think that's why nowadays they have grounding rods go, you know, instead of using the water pipes. So I think that's to come up to code. I think that's an old school thing, you know, and if you're gonna be running any of these newer, more modern houses, that's all code is to put a grounding rod in. If
Right.
you're especially going to be putting a sub panel or anything like that at all, where you have to have the thing grounded. They'll put a copper pipe about 6 feet into the ground and hook onto that.
So far, I just left it tied to the pipe. Otherwise, I got to drill a hole in the concrete and pound in a new rod.
Oh, jeez. Well, if it works, don't fix it. But I mean, that's, you know, when they're building new stuff, that's the way they do it. So
Well, yeah, if our pipe ever goes between here and the road, they probably won't put in galvanized. Probably not even copper. I don't know.
Yeah,
It's all PEX nowadays.
yeah, it's all PEX.
Guys, I'm going to bow out. It's getting late here on the East Coast.
Well, I'll bet it is. Yeah.
This has been a lot of fun.
Well, thanks so much,
Yeah.
Rick. I sure
Really
appreciate
enjoyed
it.
this 570.
Thanks, Rick.
Thanks for your dim bulb there.
Yeah, good
Sure.
presentation, Rick.
We'll see you next week.
We'll see you.
I think I'll dive out of here too.
Yeah, I am
Later.
too.
All right.
Thank you, Bruce.
You
Thanks,
betcha.
Thank you, Bruce.